the other one. So let's have our example here, and it's saying that the forces of 8 Newton and 6 newtons acts on a body with an angle of 150 degrees between them, and then find the magnitude and direction of the resultant force. Okay? So, if we are having this is now testing the idea of having obtuse angle. The first example tested acute angle. Now, if we have obtuse angle, we agreed under our note that it is like we have something like this. This one can be 8, this one can be 6, okay? And then what is true is that my resultant can now be here as R. Already I've told you here the angle is 150 degrees. So that means if I complete my parallelogram, it should be something like this. And this is the 8 newtons. This is the 6 newtons. And now this is equivalent to the angle alpha. This is A, B, C, and then D. So that is how my parallelogram is supposed to look like. And it is very encouraging to tell you that this angle here will be 30, because we know this one as well will be equal to 30. Total angle is 180, and this angle is the same as that. So that is very true. So if that is very true, we can now say, using the parallelogram, what? That resultant force should be the root of F1 squared plus F2 squared, and then plus 2 F1 F2 cos of the angle. But we are going to take F1 to be the force of 8 Newton, and we take F2 as the force of 6 Newton, and then theta our angle of 150. Is that okay? Theta our angle of 150. That implies that my R here will be equivalent to the root of 8 squared, and then I have here 6 squared plus 2 times 8 times 6, and then cos of 150 degrees. Please, I request and invite you that pick your calculator and we press the value and see what happens. The saying is supposed to be 8 squared plus 6 squared, and then plus, open bracket, 2 times 6 times 8, and then times the cos of 150. Close the bracket. So that is that. So root of the answer. This is giving me 4 okay, and now we can now decide to round off to our 4 decimal places, because we say number 1, we first write whichever thing that the calculator gives us, and then finally we can now bring it to the order of our accuracy. So that is the resultant of the forces. But please, we said we should define a force by the magnitude and the direction. And then let's look at how do we then get the direction. we can look at considering triangle ABC. Triangle ABC, what I'm meaning is, should look like this. This is the alpha, this is the 6 Newton, and then this is the 8 Newton, and then this is my 30, and then this is my resultant. This is A, B, C. And then using my sine rule, I can say 8 out of sine of alpha should be equaling to R out of sine 30. Okay? And then I can say that sine alpha is equaling to 8 sine of 30 divided by R. But we have agreed that alpha should be equal to 4.1063. And my alpha is supposed to be the sine arc of 8 sine of 30 degrees out of 4.1063. And my alpha is a value that I'm also still telling you that get, and then we press and see. Please make sure that your calculator is not in a radian. So we shall say it is 8 sine of 30, and then we are supposed to divide by 4.1063, which is giving that, and then shift the sine inverse of the answer to give us 76.93 something, 76.9347, or you can take this one as approximately 77. That is allowed here. So and then you make a conclusion that therefore the resultant force is 4.1063 at 77 degrees above the 6 Newton forces. Okay, so that will be the solution to our problem. But you should note that it is not a must that always the first force can be here and then the second one here. You can alternate the order. So don't ask yourself why. So you can even try to say 6 is here, 4 is here. You will get the same answer. Okay? You get the same thing. Only that what is very important is that you should see how the drawings are acting. For drawings which are like this, if I had maybe 6 Newton and then this one instead is entering here as 4 Newtons, okay? You cannot complete a parallelogram and pick if at all this force is entering. All of them should be moving out of that point, and then that will work. So if instead one of the forces is entering, you should try and find where all of them are leaving, and that is transforming this one as 6 here. So that means that your force is supposed to look like this. Come at a junction where all of them are leaving, and then the resultant is here. But if you use parallelogram on things of this type, this force is entering and I'm getting resultant here, you're going to get your own answer. Okay? So it only works for concurrent forces, isn't it? But moving away from some point. So if we have a different formula like I've illustrated here, that if I have 6, the other one is entering, don't say the resultant is here. Instead, transform this 6 and say this 6 can be here, and then the resultant instead be here. And that basically gives different answer from someone who's thinking in terms of getting the resultant as that. So be very, very careful. So get more example from Mr. Sadler about this.